2节课放在周五是会很累的。
Okay, so, oh, I just unplugged. Nope, we're good. I'm not going to touch it. There we go. Oh no, that one's now off. Oh, there we go. It's back. Okay, testing in practice. So now we're going to talk about what it looks like to actually do testing in a production environment. Previously, what we were just talking about, we were looking at tests in a kind of a small sort of macro way. We were looking primarily at unit tests, which are your sort of lowest level kind of test. And we were mostly looking at kind of tactically, how do you actually write tests and add them to your projects, right? We started to talk with the tags and the test suites a little bit about some of the stuff that we're going to get into here. But this is basically going to be sort of a guide to how to actually use automated testing as a professional who's writing code. So the first thing we're going to talk about is a concept called test-driven development, also known as TDD. TDD is an idea that's been around since I think the 90s or 80s. It's been here a long time. It was advocated, I believe, at first as kind of a very strong part of the Agile movement, which was a sort of rebellion of, people who write software, recognizing that writing software is complicated and messy and deadlines are very difficult, and advocating for a management style that favors flexibility over extremely strict requirements and deadlines and, basically school. So TDD is kind of a part of that, but not exactly. It's related. Test-driven development is, as its name kind of implies, you drive your development from tests. You have a testing first mindset. A lot of people who advocate for TDD are those same people I was telling you don't like using @testable on your imports, right? The folks who say, oh, well, you should only ever, be testing the things that are public in the module or in the library. And those are the things, and if you have something that's private that you want to test, you need to be able to reach it from your public API. That's their opinion. They're wrong, in my opinion, but whatever. Anyway, so the idea is that you write the test first before you've written your code. And then you write the code to make the test pass afterwards. We kind of looked at that a little bit when we talked about using the test to help us understand, okay, cool, we've got this, 32.33336, but we'd prefer it to be 32.336. So let's make the test expect that and fail until we fix the code to do it. It's a very similar idea, right? But with test-driven development, you're doing that from the very, very beginning, okay? In their mind, the very first starts of test-driven development used to be like, if the test won't compile, that's a failure, right? Now we don't even run tests if it can't compile, especially in Swift, which is very strongly typed. So, it's not quite as relevant in that way. You can't actually write the test for the types that don't exist without it, and then run the test and have it fail because the type doesn't exist. That's literally not a thing you can do in Swift. It won't even compile the test, right? But the idea is that you write the test first because it ensures that your code is built for real use cases. As developers, we can have a tendency to look at something and say, oh, this is a really cool function that I'm writing. It does this really cool thing. But what if I wanted to configure it in a different way? What if I wanted to use it in some other way? You might want to genericize it and make it, cover more general cases. You might want to make another function with a different configuration, right? You might add functionality to your application before it's needed, right? That's very common. I did it earlier today, okay? And it is something that you typically want to avoid. If you know you're going to need it eventually, you can probably write it. But if you don't know, you should probably avoid writing it. If you do test-driven development, you will only ever write code that you actually are going to use because you're writing a test for it, right? And presumably your test relates to a real world use case that your users of your app expect to be able to do, right? You drive your tests from some design document that says the user shall do this, that, and the other thing. And then you write a test that has the user do this, that, and the other thing, right? With your functions. So that's what it says that it ensures. That's what the idea says it ensures. In practice, though, it doesn't always work out that way, right? That tendency that we have to try and genericize and generalize can crop up with tests too. We can still look at them and say, gosh, this is really cool, but like, what if I wanted to genericize this? Or what if I wanted to like configure it in a different way? I'll write a test for configuring it in a different way. And then you go and write it, right? So it's the same problem, it just happens in a different order, right? The main thing to remember about test-driven development, though, is that, proponents of it, good for them, awesome. They will make claims like they program 15% faster than they did before they were on test-driven, right? All this stuff. You can just say, oh, that's nice. And it's fine. People who do test-driven development, there's nothing wrong with them, right? And, you can work with them just fine. They just code in a different way. In fact, this might sound very appealing to you. You might try it and it really works. That's awesome. It's, again, a personal preference thing. Sometimes people can be a little dogmatic and they'll say, well, everyone should use test-driven development. It's like, well, everyone has differently shaped brains, my dude. Maybe we all do things our own way. But test-driven did teach us something that we all should do, which is write tests as we go. We should not say, cool, I'm going to build out this feature, and then at the very end, right before submitting it to the mainline branch, I'll write all the tests for it. That way lies not getting your tests added to the repository. That way lies not writing tests at all. You need to make sure that as you're writing your functionality, you are creating tests for it as you go. If you do that by writing the tests first, great. If you do it by writing the tests after, great. As long as you're writing them together, right? That's the thing to take away from test-driven, if anything. And then if you want to take more from it, awesome. Just don't try and convince other people that they must do it. That's not a good look. Okay. Yeah. So if we build the tests as we go, we get the supposed benefits without any of the drawbacks. Cool. Okay, that's test-driven. Let's talk about best practices. So this is kind of related to what we were just talking about. The idea of writing tests as we go, that's considered a best practice for unit tests, right? The other one, the most important thing about unit tests, other than the fact that they actually test useful stuff and they be correct and everything else, right? Like the third most important thing, I guess, technically about unit tests, is that they are fast, okay? Unit tests should run fast, like Sonic. But not this Sonic. He's not fast enough. They need to run really fast, like really fast. Even 90s cartoon Sonic, I don't know, man, it's not quite there. Like, faster than you can compile, if possible, right? Less than a second for thousands of tests. Hundreds of thousands of them in less than a second, right? As many tests as you can. As fast as Sonic, faster, right? You've got to go fast with your tests. It's one of the most important things for unit tests. Why is that? Why do we care so much about the speed of unit tests, right? Well, we care about the speed of unit tests because if they're not fast, we won't run them. We know this about ourselves. As software developers, trying to ship something out to production late at night, it's 2 a.m., you're coding again, you didn't listen to Professor Dan, you've got Mountain Dew in one hand and, I don't know, green tea in the other. We're in 2025, it's not Mountain Dew anymore, it's something else, right? But the point is that you're coding at 2 a.m., you have something that you want to submit, and if your unit tests take 5 minutes to run, you're not going to run them. You want to brush your teeth and go to bed, right? You do not want to take that 5 minutes to make sure that all of your tests pass. It feels bad to do it. If your tests run in less than a second, you will hit that button like that because you get instantaneous validation that what you wrote didn't break something that already existed. And that is the value of a unit test. And it is only valuable if you use it, and you'll only use it if they're fast. So anything that slows your unit tests down should not be in your unit tests. That is best practice. It's why they're called unit tests instead of the other two layers, which we'll look at in a moment. The other thing that you should do with unit tests, and this is related to the gotta go fast thing, is use mocks. Now, I'm not going to dive too deeply on mocks here with you. They are a very complicated subject. They could take up a whole class of their own if we wanted to, but we're not going to do that. The idea behind mocks is that a mock is a wrapper. It is a type that you create within your test suite. It does not have tests within it, but it has the same public interface as one of your types that you use in production, right? So in your library that you're testing, let's say you use URL session or something like that. You could have a URL session mock that basically looks exactly like URL session. It has all of the same functions, the entire same public API, right? It does all of that stuff. And then what you can do is that you can make it so that the code that you're testing, rather than just when you make a network call, rather than just using URL network session or URL session.shared and then a bunch of stuff, you can instead tell it, hey, we get this passed in through the initializer. Or someone sets this on one of our public properties, right? Someone's giving us the URL session. And then we use that URL session to do all of our network calls, right? We trust that we were given a URL session that works, right? In your test, you betray that trust. You take it away from them and you say, no network calls for you, they're slow. You can't go fast if you're hitting the network. The network is really slow. So you put a wrapper around URL session, you pass your fake session to the test, and then you feed your test false data from the network in order to allow your other code to run so that you can test your other code. So this is easiest to implement. Mocks are easiest to implement if most of your types have their dependencies, like URL session, injected. And injected is, as I just said, either it is defined in the initializer or it is a property that gets set by some external actor, someone who owns that type and creates it, right? The idea is that you never instantiate your dependencies. They get injected into the type. The other thing that helps make this easy to implement is if the injected dependency is a protocol instead of an actual concrete type. So URL session, for example, is not a protocol. It is in fact a concrete type. So what does this mean? Well, if you want your code to be testable, and we do, right? And you want to do it in a way where you're not hitting the network, which we do, then what you would do is you would create your own protocol with all of the same function names and everything as URL session. And then you would use an extension on URL session to have URL session conform to your protocol. And then you can write your mock so that it conforms to the protocol, but never hits the network and instead feeds you fake network data. And then in your test, you pass in the fake network type that is implementing the protocol that your code that you're testing is expecting. Okay. That sort of dependency injection approach to how you should kind of abstract away your dependencies so that you're not relying directly on some external library, that you are instead relying on something that you have defined and can control. And then as a result, you can swap out what's underneath the hood. It's a design pattern called facade. You don't need to know that, but it's helpful. it's considered a best practice for both coding and testing. Now, there are some dependencies that you really can't mock. There are some that you just really can't, URL session, like the example I gave, you could do that. It's kind of a pain. Swift data is an excellent example of something that it's really, really hard to mock because you're using app model, you're using app relationship, inverse, and all that stuff, and you have to figure out a way to mock all of that. Now, a lot of these libraries that Apple gives do give you the ability to do things like turn off network calls and stuff like that so that you can use them while doing tests. But you need to basically, for each of these dependencies, look into how Apple expects you to use or not use them in your unit tests. Okay, cool. So, oh my gosh, I have a whole slide about what dependency injection is. Apologies, I just explained it. All right, dependency injection is fancy words for passing in references. As I said, it's often done in the constructor. Sometimes it can be done on the properties, right? And basically your type avoids creating its own instances of them. They get passed in. That's pretty much it. Okay, so another best practice when testing is thinking about what it is that we actually want to validate. The things that we want the test to actually test, right? We talked about testing for correctness, right? We saw that talking about testing for incorrectness, unhappy paths, things where we throw, where we think we should be throwing, right? And then we haven't exactly talked about it, but there's a concept called edge cases. Basically, it's a form of incorrectness where it's like right on the line of what should be correct. You tend to have most errors in that area. Things like off by one errors with an array, right? Those count as edge cases because they're right on the edge of what's acceptable. If you have a range of values that are acceptable right on the edge, those are the most valuable kinds of incorrectness to test. They give you the most bang for your buck because they are the things that are most likely to go wrong first, right? And then lastly, for incorrectness, there's also something called chaos testing, which is the exact opposite of edge cases, right? Where you just throw shit at the wall and see what doesn't stick, right? You basically say, I'm gonna just pass it nonsense, right? We saw a little bit example of that when I had the invalid inputs array that I was creating in our test in the live coding segment. That was a form of chaos testing when I was passing in strings to an arithmetic regex, like to a function that was expecting an arithmetic regex, okay? Like just a random gibberish string. That's chaos testing. So, and then of course, the other thing to validate is error handling, that you are actually handling any errors that do occur correctly, that you're doing it in the right way. So it's correct incorrectness is one way of putting it, but error handling I feel like it's easier because otherwise you're like correctness, incorrectness, and correct incorrectness. It's like, like one of those tongue twisters, right? Cool. Okay. So we've been talking about unit tests pretty much this whole time, and that is the lowest layer of tests. There's also something called integration tests. Sometimes you do need to be slow. These are the middle layer of testing. Integration tests are tests that you use to make sure that the way that you work with dependencies is correct, okay? So, yes, you should absolutely be using mocks for URL session, but you also want to make sure that you know how to properly handle random input from the network on occasion, right? So you will probably create at some point some tests that actually do hit the network and actually get data back from the backend, because you want to make sure that if they change the backend randomly, you know immediately, right? Or if not immediately, very soon. And that's what an integration test is for. If you're in a large corporation where there's over 1,000 teams and your team A in org, 32 over here, and you depend on a service owned by like, team Y in organization 57 over here, and you don't even share an SVP, your closest common denominator up top is the CEO, right? Communication lines are not going to be very good between your two teams, which means they might make changes that break your app. Integration tests can help you know that your app is going to break well before your users know. So They are good to have because of that. They make sure that updates to the dependencies don't break your code. But the problem with them is that they run super slow compared to unit tests. Remember, we have this adage that the tests have to be fast or we won't run them, right? It just won't happen when we're under pressure, okay? But the environment I'm describing with the over 1,000 teams, right? Usually you'll have something called continuous integration and continuous deployment set up, where when you check your code into the repository, it will then automatically kick off a series of build processes that will culminate eventually in your application either being sent out as a beta test to all the people who are allowed to use it as a beta test on their devices, or if it's a website, it might actually just publish it straight to production, right? But along the way, it's going to do a lot of checking and validation to make sure you didn't break something. Amongst those things are unit tests, of course, but because you're about to go out to a production environment, you need to make sure that all of your dependencies and all of the API calls you're making all work right. And that's where integration tests come in. So unit tests are for while you're compiling and writing code and before you submit it to the repository. Integration tests are usually run after you submit to the repository, but before the code gets deployed to production, right? And so it's okay that they run super slow because they only run, I don't know, once a day, right? You have a nightly build maybe, that's really fast. CI/CD that does a new build every night is really fast. So, you know, it's slow compared to unit tests, but it's, you know, it can be fast compared to an entire build process, which can take hours sometimes. So, as a result, because they're slow, you should use them sparingly, especially if you're not in the situation I described at a massive company with 1,000 teams and a whole CI/CD pipeline. If you're doing this for yourself or for your personal project, avoid integration tests or have maybe like 3, and don't run them as a part of your regular testing. Run them, you know, right before you submit something to me. Make sure that everything works. Or not right before, do it well before so you can fix any errors, but like, you know, use it on occasion, don't use it every time. With unit tests, you want to run them almost every time you compile. With integration tests, you want to run them once or twice a day. Okay, so another reason why we might want integration tests that are slow is you can't do dependency injection. Sometimes it just doesn't work. As I was saying, with Swift data, it would be very, very hard to create a mock of Swift data and use that for dependency injection. So anytime you are using some external dependency that is slow, like a database, a local database, like with Swift data, that's an integration test. And because we can't mock it, or it's harder to mock it anyway, we can have our unit tests that are testing a bunch of things, but there will likely be some pieces of flow, parts of how functions connect to functions that we want to make sure work right. And that's going to involve hitting the database and coming back and hitting the database and coming back. So it's going to be slow. So that would be something that we would make in integration tests. When you're dealing with legacy code, sometimes if you're dealing with legacy code, old code written by someone else in the yesteryears of 2017, perhaps, or even older, right? 2005, right? You probably won't run into code from the 90s anymore. Not you guys. I know some people who do, but anyway, yeah. When dealing with legacy code, some of these patterns weren't used. Sometimes the person did know the patterns, but they didn't use them because they were in a rush. They were under a tight deadline. They needed to get it out. They couldn't do it right. Sometimes they just don't do dependency injection for their dependencies. They just create it in line, or they use the shared singleton or whatever, right? And then it's done, right? In those cases, if you rely on that legacy code in your code because it's doing something important that you need to do that's crucial to the business, and you haven't had time to go in and make it better and modularize it and improve it, right, and refactor it, then you're going to have to make sure that any tests that are calling into that are integration tests because you don't have control and you can't do the dependency injection, which means they are probably hitting a database or a network that is slow. There are also there's a concept. So a lot of what we've learned here is a form of object-oriented programming, although Apple likes to call it protocol-oriented programming because they're pretentious. There's also functional programming. There's a third kind of programming called aspect-oriented programming. It was really hot in the 2000s, but in the end, people realized it was pretty much primarily only useful for like logging. So logging things to the console or emitting metrics. So you'll encounter aspect-oriented architectures on occasion. I cannot tell you what to look for to identify if it's aspect-oriented or not. I'm sorry. I just know it when I see it. I've never written one myself. Basically it like smears itself across the entire code base and it gets used everywhere in a certain way. But it's okay. It doesn't break, good coding practices because it uses aspects to do it. I don't know. Okay, whatever. I think it's like component based. I'm not sure. The point is, that's a situation where it's very hard to do dependency injection. And so when you're interacting with something like a logging system, you want to make sure that you're logging your metrics correctly or you're outputting to the console right. You might not be able to do a dependency injection, so you might have to make that an integration test. When you're dealing with complex interconnected state, so if you have like a bunch of references that all interact with each other and they change each other's state and they're not thread safe and they're not concurrency safe, right? Your tests, you just can't run them quickly because you have to run them one at a time. Otherwise, they'll just interact with each other poorly, right? You probably have to kind of take those tests and narrow them down to be a little bit, smaller in, the number of tests and move them to your integration test suite because otherwise you're going to be slowing down your unit tests, right? And then sometimes, on rare occasions, you need data input from a framework that you can't mock. So sometimes the data comes to you in a form that you can't fake. You don't have a way to fake it, right? Some non-standard file format, like a .zsd file, and you just don't have a 3D modeling program on your laptop, and you're not going to pay $100 to get one just so you can write good unit tests like Professor Dan told you to, right? In that case, please make an integration test. Don't pay $100 to get a program like Maya. That would be ridiculous, right? So sometimes external circumstances require us to do that. And then, as I said before, verify contracts before shipping. That was the example I gave with when you're in a company with 1,000 teams and you want to make sure that changes that a dependency of yours or an upstream dependency of yours made didn't break your code. That's what integration tests are for. Okay. UI tests. So we've talked about unit tests, which are the lowest level, blisteringly fast tests. We've talked about integration tests. They're pretty slow. They're kind of plodding. They take their time, right? We don't really have a time limit on them. We try to make as few of them as we can. And we try to run them as infrequently as we can, right? Integration tests are the middle layer, okay? Finally, the last layer, the very top, the one that you will probably never run into yourself while at school, and it will be a while before you run into it in industry, unless you go somewhere like Amazon or something, I don't know. And even there, I never interacted with our UI tests. That was done by a whole suite of test engineers. That was their whole job, was just maintaining our UI tests. They are the top layer. They are the layer closest to the user. They pretend to be the user, okay? So automated UI testing, basically, it's the highest layer, and it doesn't really care about the underlying code at all. What it cares about is your user interface. It's in the name, UI testing, user interface testing. You're just testing if the user interface does what you expect it to. A manual form of UI testing is what you do whenever you open up your app after you made some changes and poke some buttons and say, oh, there's the spinner, right? And you should all have a spinner. So automated UI testing checks to make sure there's a spinner for you so that you don't have to do it. Sounds great, right? Okay, well, there's complications. It simulates a user interacting with your UI. But the question is how? How does it simulate that? That's the difficult part. Because it's simulating user interaction with the UI, it's very, very brittle. So depending on how the user interface test is set up, depending on its underlying technology, you might end up with a situation where if you move a button 3 pixels to the left, your test breaks, right? Which is, of course, not intended behavior, right? You don't care if the button is 3 pixels to the right, or left, sorry. But the UI test might, depending on how it was written. So you need to be very careful with them because they are very brittle. They're very easy to break. And you get to a point very quickly, if you have a huge suite of them, where one's always broken. And then you're like, whatever, we need to ship. Let's just send it out. We're just going to disable UI tests in the pipeline and we'll fix them later. And every team I've ever been on that has UI tests has said the same thing and never ever fixed them. So, UI tests, easy to break, hard to fix, hard to maintain. Value gained, you know, there's some value. It depends. If you're a very small group or a very small studio and you don't have the money to pay for a suite of manual testers, you know, offshore or even here, right? You know, just people who go in, they like, okay, here's the test plan. Okay, so I go to the home screen and then I hit this button and then I do this. I should see this. I do, check, right? Suites of manual testers, you know, Amazon has hordes of them all over the world. And they basically just do that. They get a test plan and they run through the application and they make sure it works. Because UI tests are so much more expensive to maintain from a pure dollar standpoint than just having someone whose day job is to do that. When you're operating at Amazon's scale, right? That's the case. But if you're a small studio, it might be the other way around, where the UI tests, while they might be brittle, if you have them in a targeted, very, you know, smart way where you only have like 3 or 4 for your like core flows, right? They can work really well and save you a lot of time and money. So, but I mentioned the underlying technology for UI testing. So basically there's kind of 2 ways you can go about UI testing, right? The first one are pixel-based actions. So these are basically saying, when you write your UI test, you'll say, okay, so first, the user taps on pixel at coordinate x36, y87. And so the app loads up and it simulates a user tapping that pixel on the screen, okay? This is the situation that I was describing where if the button gets moved slightly down or slightly up, this might miss and your test might fail, even though any reasonable manual tester won't care. They're going to look for the button with that name and they're going to click on it, right? That's what they're going to do, okay? But because UI tests are operating on top of our app, they're not a part of our app's code. They receive the app as a bundle and then they run on top of it. They don't have access to our internal types. So they can't look at our code and say, okay, I want to find the button that's currently loaded into memory with the name show my spinner, right? The UI test doesn't have access to that information. It's hidden from it. It's obfuscated, right? All it can do is interact with the app in the same way a person can, okay? So we've got pixel-based actions, which are very prone to error, as I said, and they are very brittle. They're very easy to break. And they are very hard to write. You know, I mean, even just describing that first action, right? It was painful for me, right? And that was the first action. A UI test is going to have many actions chained together. And that's just one test, right? So it's just a huge pain. And then you have to write a different one for different form factors. Oh, cool, someone's got an iPhone 16e. Well, okay, the pixel number is different on that. Oh, someone's doing this on an iPad. Well, the pixel number is different on that. So now for every UI test you write, you have to also write a test for every single form factor that exists if you want to make sure that your app works correctly on it, right? And you're starting to see the issues that arise, right? More modern UI testing frameworks now use accessibility-driven UI tests. So with accessibility-driven UI tests, as I mentioned, the test suite doesn't have access to your internal types or information in memory because, you know, it's external. It's not a part of the app. It's outside of the app, right? That's why it's valuable as a UI test. Otherwise, you're just doing integration tests. But your UI test, you know, outside, it can see the things that a user could see. So it could be doing this pixel-based thing, or you could use something called accessibility-driven UI tests. So we haven't talked too much about accessibility, but Apple is very, 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 very good at making accessibility a constant, common thing that you have available to all of your views in SwiftUI and UIKit. If you've ever been at the end of a view and you're looking to add some modifiers, and you hit the dot key, and you want to see just the functions that you care about the most, you know, the ones that you'll actually use, right? There's like 3 at the top, and then there's like 20 that start with accessibility, right? You've probably seen this. If you haven't, then I don't know, share with me your secrets, because you know, sometimes I just want to see other functions other than accessibility functions. But if you make your app accessible, so if you add voiceover tags to your UI elements, if you say, oh, cool, so this button is a accessible UI element. So it has a voiceover tag that reads out, you know, show my spinner, whatever, right? The way that the voiceover does, right? And then, you know, it'll get highlighted by the voiceover and all that stuff, right? Doing that, setting that up, allows a UI test to hook into and use those voiceover actions and abilities. So accessibility, you know, you can click, you know, there's an input action where you can say, just go to the next element, right? And the highlight box will go to the next element on the screen, right? And if you set up your accessibility right, you're picking which elements are the next ones. You're making sure that everything is accessible and selectable, that it says something intelligent when you select it, that helps the user understand where to go and what to do, right? So if your app is fully accessible, then UI tests can hook into this. And you can write UI tests to say, go to the next element, press on the button that, you know, make sure that the button's voiceover says this, right? And then click on it. And then verify that a spinner shows up, right? It can do all of that because that information is available in the accessibility engine, which is available to the exterior watchers of the application. It is far less brittle to do things this way, but it is still quite brittle. It will expect things like needing the order to be the same, or the name or the text that VoiceOver says for the button to remain the same. And if that changes, you have to change the test, right? So it's way less brittle than pixel-based, but it's still more brittle than integration tests are. So, testing complex code. Sorry, before I move on, are there any questions about UI tests before I move on? Okay. Again, UI tests, you're probably never going to really use them. You can create UI tests in Xcode. That was the other kind of testing bundle you could make. If you're interested, feel free to look into it. I would say wait to do it until after you finish the final project, just so that you have, you know, time to finish the final project. Yeah. So, testing complex code. We talked about this a little bit with dependency injection and being able to, you know, kind of mock and wrap around things. And I believe I didn't actually finish this deck, so this next button is going to close the slide deck. Yes. Okay. So testing complex code is difficult, but essentially the idea behind it is that you can write tests in a kind of exterior sort of way, and then use them to refactor your code safely. So you write a test all the way around a big fat integration test that runs real slow, right? It's gross and ugly and you don't like it, right? But you've got it for a short period of time. You're making it a temporary thing as you transition this nasty, complex legacy code into something that's more testable and easy to verify and dependency inject into, right? So you write your big, nasty integration test, right? And then there are ways where you can go in and you can make modifications to that complex code without changing its public-facing API. And you can fix it from the inside out, and then your test is verifying that you're not breaking anything the entire time. Because the nastiest, worst part about complex code that is complicated and poorly made and doesn't run right and you just want to get rid of it is that it has insane business value, almost always. There are use cases for your users that many of your users use that are hiding inside of that complex code that you have no idea exist, your PM has no idea exists, and your manager have no idea exists. No one knows it's there, but it's there, and you're gonna miss it if you don't properly wrap your test, a big fat intake test around the complex code and try to make sure that you exercise as much of it as you can using code coverage. This is one of those situations where you do want to strive for a very good amount of code coverage, just around this little complex nugget, right? But you don't understand what's happening in there, but you want to make sure that you don't change any of the logic. You just make it easier to test. You're just breaking it apart into pieces, making it easier to test. And then once you have all of your really nice, tiny little unit tests all around it, then you can look at it and say, oh, this is what it's doing. These are the different things that our users care about, right? This is how we can make changes to the application and not break these use cases, right? So it's a form of both discovery, investigative journalism, and just like archaeology, or paleontology, I suppose. Just digging around in ancient crusty code, trying to brush the dust away from the bones without cracking any of them, right? It's more like archaeology, actually. Yeah. So, that's how you test complex code. Sorry, I didn't have a slide for it. Any questions about testing, be it automated, UI, unit, or integration? Awesome. Okay. I'm gonna stop the recording, and then I'm going to open the floor for questions.